Alright, so I'm going to be showing how to do the fluid flow simulation around an airfoil in a wind tunnel at 60 Hertz. So we're going to go ahead and start with Fluent Flow Fluent in ANSYS Workbench, and we're going to change the geometry from 3D to 2D. We're going to go ahead and import our geometry. I've already modeled it in Fusion. And then we're going to go ahead and edit the mesh. Right, so we're going to go ahead and insert a method in the mesh, and we're going to click on our wind tunnel and click down here, click apply, and change from quadrilateral dominant to triangles. And then we're going to click on our mesh and change the element size to 0.005. And go ahead and click generate. And here's our mesh. Now we got to do our name selection. So we're going to start by doing the velocity inlet. And then we can do the pressure outlet. Now we will do the wind tunnel wall. This one we got to go into the drop down, click wind tunnel wall so we can add the rest of the components of the wall. And now we can go ahead and zoom in and also do our airfoil. I have to zoom in quite a lot. Right. On this little edge here. And we're going to call it internal. Oop, that added it to the wind tunnel wall. We don't want to do that. There we go. And that is all we need to do for our meshing. So we're going to go back into Workbench now. Maybe. All right, we're going to go right click and update the mesh. And now we can start our setup. So click edit. And we need to check double precision here and click start. Right, so it got our inlet and outlet correct. We're going to go ahead and adjust our inputs to the simulation. So we're going to turn on energy, and then we're going to change our viscous to K epsilon. And now we're going to go ahead and check our materials. We've got air, but we're going to change our density to 1.204 because that should be about what it was in the room that we were at. And we're going to change our inlet velocity right now to the inlet for 60 Hertz, which is about 3.804 meters per second. And that should be everything for that. Now we just need to go ahead and add our report definitions so that we can get the drag force and lift force reports out. We do also need to get drag coefficients and lift coefficients for some of these simulations. However, we're going to calculate those manually, so we're just going to get a report of the forces. And make sure that we're selecting internal for these so that we're getting only on the internal body in the test section, so the airfoil, and not the walls of the wind tunnel. Just check that we did that for drag. Yes. Okay. Now we can go ahead and initialize. We're going to do a standard initialization. Again, our velocity is 3.804 and our temperature is 293. That was about the room temperature in the room that we were in, and we're going to initialize. All right, so we have initialized, and we're going to go ahead and run calculation now. There we go. I'm going to change to 100 iterations and calculate. Right, so now that we're done calculating, we can go ahead and look at what our lift and drag forces were. So we're going to go ahead and go back to report conditions, click on lift, and we're going to go ahead and click compute, and it shows us our lift force down here was 0.0069 newtons. And then we can find the drag force by doing the same thing. Compute, and we've got a drag force of 0.054 newtons. And now we need to add in our contours, so we can go ahead and go into this graphics drop down, right click on contours, click new, and we can start with the static pressure. So we can just click save display, and let's zoom in so that we can get a better view of the actual airfoil itself. Let's get the edges of the wall as well, because that's going to change with boundary. So there is our static pressure. Now we can add a dynamic pressure contour as well. This drop down, click dynamic pressure, display that one. And you can see we've got a little bit of a wake region behind the airfoil. Add the total pressure contour. Total pressure in this drop down. And again, you see the same wake region